Recursion is very common in linked list processing when constructing a new linked list or taking an existing linked list and doing something with it. Let's look at some examples. Ranges are built in, the map function's built in, and the filter function's built into Python, but they don't operate on linked lists because those are user-defined. So if we want the same functionality, we'll have to implement our own notion of range and map and filter. Let's remember what these things do. If I have two functions like square, which takes an x and squares it, and odd, which takes an x and returns whether it's an odd number, then I could, for example, write the following expression using the built-in map and filter and range. Get the numbers 1, 2, 3, 4, and 5, filter for only the odd ones. So now I have 1, 3, and 5, and then map the square function over those. So 1 squared is 1, 3 squared is 9, and 5 squared is 25. Those results we'll place in a list. The same kind of thing could be done with linked lists using the class that we just defined, but the syntax will be slightly different. We'll have to come up with a maplink function, which we'll implement momentarily, which takes a square and squares all the elements of the result of filtering a linked list using the odd function, where we start with a linked list representing the range 1, 2, 3, 4, 5. Filter out the 2 and the 4 to just have 1, 3, and 5, the odd ones, square all of those, and you get a linked list of 1, 9, and 25. So let's go through and implement rangeLink, which has a starting integer and an ending integer and returns a link containing consecutive integers from start, including the start, to end, not including the end. So the rangeLink from 3 to 6 would be 3, 4, and 5. And we'll also write maplink, which returns a new linked list that contains f of x for every x in the original linked list s. So if we square everything in the range 3 to 6, then we get 3 squared, 4 squared, and 5 squared. And we'll also write filterLink, which returns a linked list that contains only the elements of link s, for which f called on that element returns a true value. So if we filter for only the odd elements of this range, then we get 3 and 5, leaving out the 4. Actually, all of these are going to be recursive functions. So here's our link class. Here's square and odd. And how do we build a range? Well, if it's the case that start is greater than or equal to end, then there's nothing in the range. We return link.empty to represent an empty linked list. Otherwise, there's at least one element in the range, and that is the start element, followed by some other stuff. Return a link with start as the first element. And what's the rest of the range? Well, that is the range that starts at start plus 1 and goes to the end. How do we take a function and map it over all the elements in S, calling f on every single element and building a linked list of the result? If it's the case that S is link.empty, there's really no work to do. We could return S or return link.empty. Since those are just two expressions for the same thing, it doesn't matter which one you write. Otherwise, you know there's at least one element, so let's call f on it. And we'll return a new linked list, with its first element being the result of calling f on the first element of S. And then we need to call f on the rest of the elements. We do that with a recursive call to maplink, where we're calling the same function f on everything in s.rest. And what about filtering? Well, if s is link.empty, again, there's no elements to filter, so we'll return s. Otherwise, I do think that we need to filter everything in the rest of s, so let's get the filtered rest, which is the result of calling filterLink using that same f on the rest of s. But now we have to make a decision. Is it the case that s.first is in the result or not? Well, that depends on what you get when you call f on s.first. If that's a true value, then we need s.first to be in the result. And what's everything else? Well, that's the result of filtering the rest of the list. Otherwise, if this is a false value, then s.first is not supposed to be in the result, so we can just return the filtered rest. Let's check to see if our doc tests all work. Oh, they do. So it should be the case that if I start with a range from 1 to 6, so that's 1, 2, 3, 4, and 5, I filter it using odd, I map the square function over the result, then what I get is 1, 9, 16.